Hello everybody and welcome back. So in this next lesson we're going to be moving on with learning a class that is very important to working with Python in Houdini, and that is the who.parm class. So again, we're going to open up our help browser because it's always very useful to have this open, and we're going to search for who.parm. Now just remember, I've mentioned this before, but parm is just short for parameter. So I may interchangeably use those two words throughout, but at least you know what I'm talking about, right? So this is the class that we're going to be looking at. However, there is another class that is kind of very related to this, and that is parm tuple. So this is it's basically going to have a lot of the same functions. So it depends on which parameter type you have actually got a reference to. You'll be able to run the functions either on the parm tuple or the parm. Now there are some functions that are different. I'm not going to go through everything and show what is different between them, but if you're trying to run something on a parm and it's not working, it's complaining that it doesn't have that, well then maybe it's because you're working with a parm and you need the parm tuple, or vice versa. And you can convert from one to the other, as in from the parm there is a way to get a parm tuple, a function that actually returns the tuple of that parm, and vice versa. Now I just want to be clear about what I mean when I say a parm tuple. So this parameter over here, scale, specifically is one single parameter, right? So when I drag that in, that's going to automatically create a who.parm function reference. Okay. Whereas if we drag in the translate, it's going to give a parm tuple, because this is the actual individual parameters are tx, ty, and tz. But if we go to the parameter interface, you'll see here that it's one parameter. Okay. So it's one master parameter called a parm tuple because it has multiple values inside of it. Remember, a tuple is just an immutable list, an ordered list. Okay, so x, y, z, the order matters. They are indexed, right? But not indexed with 0, 1, 2, but instead x, y, z. Okay, so they have a naming, like a naming sort of sequence instead of 0, 1, 2, but it's still a tuple, right? One thing which has three values within it, right? So we need to be very clear about what that is, because if I refer to the parm tuple t, okay, so I can grab that parm tuple, but if I want to refer to x, I need to refer not to the parm tuple, but parm, and then the path to that parm is obj go1 tx. Okay, so you see that tx and ty and tz were in this list because I'm referring to parm, like individual parms. If I refer to parm tuples, then when I do the list, obj go1, and I type t will be in the list, and there will be no tx, ty, and tz, right? So very important distinction to understand what we're talking about. Okay, so let's move on to some basic things that we're going to do with parameters. Now, so grabbing a reference is the first thing that we're going to want to do. And obviously, as you've seen right here, it's very easy to just drag things in. But what is actually happening here? So we're running a function in the actual Houdini module, and the function is called parm, and we give it a path to the parameter, and then it returns a reference to that parameter. Okay, and the exact same thing with a parm tuple. We're just giving a parm and a path to it, and it is still a function of the Houdini module, right? However, there are other ways for us to get access to references to these parameters. One of them being through the node that they are attached to. So in here, let's go and drag n equals and then who.node, right? So I've got a reference to my actual node. Now, when I go on n, right? So on our node, we have a list of node functions, which is what we went through in the previous lesson. But one of them is parm, and also parm tuple if we want, right? So parm tuple or parm. And what this is doing is essentially like when we were selecting or getting a reference to a node that is inside of this node or relative to this node, where we can say n.node. Well, this is the same kind of thing, except this is n.parm. So not only is parm a Houdini module function, it is also a module that is inherited by the class of who.node, which means that when we run it on node like n.parm, what it's doing is it's starting from the path of this node. And since all the parameters are on the node themselves, we don't need to give the whole path. We just give the parameter name. Unless, of course, we wanted to refer to a parameter that is not on this node, but maybe on its parent or something like that. But most of the time when we're referencing a node, we're going to then be referencing a parameter on that node. And so we don't need to give any path, just its name, right? And again, if we're referring to parameters, you've got to give the parameter name, so tx, ty, and tz. If you're referring to tuples, then you refer to the tuple name. Okay, so we can go do n.parm tx, and this will refer to tx the same way that we could say who.parm, and then we here have to give the full path of obj go1 and then tx. Okay, and that will refer to the same exact node, so same parameter. Now, in a similar way to how we gathered all of the children inside of a node by doing n.children, we can also grab all of the parameters on that node by doing n.parms. Okay, so just the plural of parms. Okay, and it will return a giant list of parameters on this node. Okay, I mean, it obviously is quite a lot of parameters, because all of these are, including hidden parameters and everything, are in this list. Okay, and the exact same thing you can say n.parm tuples, and it will return a list specifically of parm tuples of everything. Okay, right? So that's how we can grab that selection. And just remember that you can also go from the tuple, from an individual parameter, you can grab the tuple, and from the tuple, then you can grab individual parameters, but not through a function, but rather the index. Okay, so 0 of this tuple is going to be tx. Okay, so you use the index to grab the individual parameter, and from the parameter to get the tuple, you just use the function tuple. All right, so just keep in mind that even nodes that have, so it's quite obvious with translate that it has a tuple and it has 3 individual parameters. What is not always understood and often overlooked is the fact that even things that have individual parameters like scale also have a tuple. It just so happens that that tuple is 1 in length, where this one parameter is the only thing in that list, but that doesn't mean that it's not still a list. It's like having a box with multiple books inside of the box, right? But you could also have a box with 1 book. That, it's still a relevant thing. That book still has a box. It's just that it's the only thing in that box. And that's what the same thing is with these tuples. This scale here, when we drag it in automatically, because Houdini is trying to preempt what we're saying, when we drag it in, it thinks that we're talking about parm instead of parm tuple, because it knows that this is only 1 parameter. But we could refer to the parm tuple at this path, and it will grab that same parm tuple, and then we can run anything we want on that parm tuple, including grabbing its first and only index 0, and it will then give us the parm instead of the parm tuple of that same parameter. Okay. Now, once we have a reference to a parameter, a lot of the time, parameters are essentially a way of feeding values into the system. Now, we are most likely going to want to work with those values. In one way, we're going to want to grab the value of a parameter, and in another way, we are going to want to change or set the value of a parameter. Okay, so let's do that. Let me just create a reference to P over here. All right. So the main way, or the kind of the key word we're looking for here is evaluate. That's what it means to get the information from a parameter. So to assess it for its current value. Now, on just static parameters with single values, that's pretty simple, but it can get a lot more complicated, as you'll see. So let me show you what we have. Now, the first most basic way is just the eval keyword, right? So this function, eval, is short for evaluate, and so we're essentially saying go to this parameter and evaluate it. So return the value of it, okay? And it will return 1. If this is set to 0.362, then is exactly what it will return, right? So it's going to give us the value. But what it's giving us is essentially the value at the, based on the current type, okay? And it's going to make certain assumptions about the type. But we can also ask specifically for a type. So we have a float here, and this is an actual float, but what if we wanted to store it in, let's say, that user data dictionary, which we spoke about at the end of the last lesson. Now, that requires a string. And sure, okay, there are multiple ways in Python to do everything, really. So you could go and just assess that and convert it into a string, right? You could. But another way is to essentially evaluate it as a string. And so when we say p.eval, you'll actually see there is a whole list of evaluate as. So it allows us to specifically typecast that evaluation. Now, some of them are not always relevant. Some of them are not going to actually work, depending. It really depends on the type of parameter that it is. But we can try a few. Evaluate as float is just going to give us the same value here because we literally have a float. But maybe let's try evaluate as int. Okay. So, right. Okay. So this is exactly it. It is a little bit temperamental. Sometimes it's not going to allow it to typecast, and so you would have to go and just basically eval it and do convert it to int, right? And it's probably unable to convert this because it won't know exactly what type of conversion you want to do. Do you want to do floor or ceiling? Do you want to just drop the fraction as in this? So that's probably one of the ways it won't work. We could take this, so we could say p.eval as string, right? And that will give us at least a string. So some of them are going to work, some of them won't, but they are relevant and necessary because sometimes we specifically want to grab their value in a certain way. You'll see here the string actually gives us many more actual sort of floating point values than this one does, right? Now, there is also, when we go p.eval, at the bottom of this list, besides the eval as something, you'll see eval at. And also for each eval as, there's an eval at. Okay. So this is specifically about, it's almost like doing a time shift. It's looking at this value and going to a particular frame and seeing what that value will be. Now, that's only really relevant if the parameter is actually time dependent, and I believe there is an actual function where you can check whether the parameter is time dependent or not. And what that means is this value is static. It really doesn't care what frame I'm on. This is one value. I've given it one value. If I've given it keyframes, then yes, it's time dependent. So now when I do that, it'll actually say true. It has a time dependency. Or instead of an keyframe, if I have an expression where it is referring to something else, then there's a good chance that the thing that it's referring to is time dependent, and therefore this parameter is time dependent. And so we can now go, and even though we're on frame 1, and so our value is 0.362, we can say p.eval at, let's say frame. There's eval at time just for if you want to use time instead of frames, so you can use seconds instead of frames, but most of the time we think in frames, so it's just easier to just feed it frame 72, and now you see it returns 0.5524 and so on, which is clearly not the value we have here. But if we go to frame 72, then you'll see that it is exactly that. Okay, so it's going to be essentially evaluating that at a particular frame. Now, be careful with this. In simple cases with keyframes, it's not too bad, but if it's very complicated, or there are lots of nodes referring, parameters referring to this value that is coming out of here, it can get very complicated because it has to cook things in order to get that value. And if that value is dependent on multiple nodes, then it has to cook all of those nodes right up to that frame. So especially if you've got a simulation, this is going to cause a lot of caching and cooking. So just be careful. But sometimes it's fine. Right. Now, I also just want to point out before we move on that I have been using just the p.eval. So we have a parameter and we are running the evaluate function. But there is also a global Houdini function, so under the who module, which is who.evalParm and then evalParm tuple. So there's always an equivalent of each one. And this is essentially a short form, although it's sometimes not always that short. But so anyway, it's a quick way of essentially referring to a parameter and immediately evaluating it without having to refer to that parameter and store it separately in a variable or just run who.parm. So essentially it's the equivalent of us going who.parm and then we give it the path to that parameter. So obj, go1, scale, okay, and then on the end of this adding on eval. The exact same equivalent is us saying who.evalParm. So what this does is immediately goes, instead of grabbing a reference to the parameter and then running the eval function within the parameter, we are just running a Houdini function called evalParm, which takes a path and evaluates the parameter at that path. So both will give us the exact same result. This one is quicker sometimes, but this one's better when you actually want to store the parameter and is some sort of variable and then evaluate it, or when we already have the parameter stored. So maybe we're looping through a list of parameters like we did here. We have a list. We would then refer to that parameter and say just .eval. But if we're wanting just to grab the value in one single line, then this is the shortest way to type it. Okay, so sometimes you'll see me use evalParm, otherwise you'll see me grab a reference to the parameter and then run the eval function on that parameter. Okay. And then there is one other type, which when we say p.eval, you assume that all of the evaluation is under this list, but there is one that's a little bit hidden, and that's because it essentially is not evaluating, but it is getting the value of a parameter, which is a little strange. So unexpanded string. Now what this does is essentially it's not going to work in this case, but what it's doing is it's returning the parameter kind of in a way where it hasn't evaluated what it's actually referring to. So let's say I was just going to grab a file over here and use a variable. So I'll say $hip / and I'll just call it something .f3.bgo.sc. Okay, so this is where I want to cache or read my cache from. Okay, and let's say p equals, and I'll refer to my node dot parm, and then we give it file, or we could have just dragged in this file. Either way, it's going to work. Okay, so we're looking at the node and then we're doing .parm, or we can say p equals and then just a path to the parm. all right? And I want you to be comfortable with both, because you need to start understanding that we're going into the module, into a function which returns a node, and then into that node class we're running the Palm function, or in this module we have one function. Different ways to do the same thing. Okay, so now what we can do is we can say p.eval, and when we eval it, look at what it's returning. This is not this. Okay, it's the result of this. If I middle click here, it evaluates the expression. So that is the same as this. That's what eval is doing, is evaluate it. And the reason why unexpanded string is not listed under eval is because it is literally not evaluating it. It is returning the unexpanded string. So we say unexpanded string, and that returns $hip with $f3. So it returns the raw string as it is, without assessing what those variables actually mean. Okay. So that's all the ways that we can kind of go and grab data. And we can also set data. Okay. So we can go and say, so let's refer to this as p. So p equals that parameter. Now we can say p.set. So it's just set, and then we give it the value that we want to give it. So let's just say 5. Okay, and now that is 5. All right. Now, some of the other things we can do, basic things with parameters, we can check its name. Now, remember, every parameter has a name and a label. Okay, so we can check the name of this parameter, right? But when we go and try and find out label, you'll find that that is not a function. Now, we are going to discuss this later on. This is a huge, whole big can of worms that we're opening here by discussing why it has a name but not a label in here. That is so big that it actually needs to be its own lesson, and in fact, depending on how much content there is, it might even split into 2 lessons. It's a very unnecessarily complicated part of the coding, but actually once you figure it out, it's not so difficult once you know what it's doing, but it's very difficult at first. So I really want to try and give it to you in a lesson that makes it clear to you, so that you don't have to struggle like I did, because when I first learned this, it was so confusing until you wrap your head around what it's actually doing, and then it actually makes logical sense. So there are going to be a few limitations with parameters, a few things you would think you can do, that a few functions that you think should live inside of this parameter who.parm class, and yet they don't. For example, creating nodes and deleting parameters. Creating and deleting parameters is not like creating and deleting nodes. It doesn't just live inside of that same module and lets you just run that function and go, oh, let me just create a node. Okay, cool, I'll just create a parameter. You cannot do it that way, right? There are a few extra steps we have to do in terms of any deep editing of parameters. Creating, deleting, checking the label, creating defaults. There's an extensive list of things that are offloaded onto a separate module that we're going to have an entire lesson around that. So for now, just trust me that there is no label function, and you'll find certain functions missing that you would expect to find. But don't worry, we will be covering it in this course in quite a bit of detail, because it's vital. You have to know it in order to create, because to create HDAs and things, you need to create parameters all the time. Okay, so I'm looking forward to getting there, because it's actually really cool to pass on that information so you guys don't have to struggle like I did. So we can grab the name. That's at least good enough. But the name, remember, is not the human readable label like this. It's, if we hover over it, you'll see the name there. So this says pivot translate, but the actual name of the parameters is px, py, pz, and the name of the tuple is p. Okay. All right. Something else we can do is do the reverse essentially of going node, so n.parm, is we're now going to say on this, I've got a reference to this parameter, but I want to know what node I am part of. Okay, so I have some random reference to this parameter, but where is it? What node is it on? Okay, so we can always grab the reference to the node just because we have the node, well, the parameter reference. Right. And then something else which is only relevant sometimes, although I wonder if there are any inside this. No, I don't see any buttons, but there are buttons on certain nodes, things like maybe let's drop down a .network. So this has a button. I mean, there's a clear button over here. There's a reset simulation button. Now these are parameters like everything else. Okay, these are actual parameters. And when we come to this reset simulation, you'll see it's just a button type, and it will have well, actually this you can't see it, but it'll run a callback. So it'll have its own sort of script that when you click this button, it does something. Okay. We can refer to these parameters also just by dragging them in, or just remember, if you hover over it, you see what the name is, resimulate. Okay. So we could just do a who.palm reference to that, or who.node, then a reference to the node, and then .palm and a reference to the parameter. So either way, we have this parameter, right? So P equals that. But if we want to essentially run the button, like as though we, the user, clicked it, then we can run a function p.pressButton. And that will operate as though it has clicked that. So if we had a simulation and I ran this, it would then go, oh, okay, and it would actually start recooking and re-simulate up to that point, right? In fact, maybe let me show you on this because this is easier. Okay, yeah, in fact, this one's harder because this is part of a multi-palm block. So this button, I'm not sure it has a name of its own. I think what we can do, let's give this a go. I think that the way to reference that is on this actual parameter. It'll be num_obj. That's the name. Let's try this. This is a total test here, but let's see. So we take the node and we say .palm, and then num_obj .press button. Maybe this will work. No. Okay. I don't know. I'll actually look into it. I'm not really sure how to refer to these buttons because you see they don't have parameter, like they don't have names. They are not actual parameters. They are part of a folder that has its own sort of inbuilt names. But if any of you do know how to refer to that, then let us know in the Discord server. And I'll look into it and I'll see if I can find it, then I'll let you guys know. So those are a little bit odd, but if you come across any other buttons or something like this is an actual parameter, then you can click that button using Python. Now something else that it can do is actually run initialized scripts and stuff. So you could say something like, I've noticed when you drop down the volume source over here, see under initialize, it's set to source smoke, but it has nothing. You have to actually click away and then click back to get it to initialize to the smoke. But if we instead wanted to just run the initial scripts on this, you can actually refer to that and say press button, and it will actually enact that, okay, as though we had kind of clicked away and clicked back to it, right? Because sometimes I worry that clicking here is going to set some sort of setting somewhere, and that maybe source smoke doesn't unset that value. And so you end up with weird results because you've gone and clicked on something and then clicked back and actually ended up with like maybe some particles in your source smoke because it hasn't been set up correctly. So I'm always wary of that. So I actually often use this to just refer to something and say press button to get it to initialize on the value that it is. So there's a couple of little hacks, and I mean we're talking about using Python on the go in this particular week. This is exactly that, using little bits of code to help you do things that you wouldn't be able to do normally. Okay. All right, so now there is another section I want to talk about which gets a little bit more advanced. So try and follow along here. In the same way that we have sort of this kind of duality between parameters and Palm tuples, there is also this kind of very weird sort of brother relationship between keyframes and expressions. And I know that sounds a little bit odd, but basically an expression counts kind of as a particular keyframe, because that keyframe can store a bunch of values. So when you have an expression on a parameter, it kind of just counts it as one keyframe that has a certain bit of data, which is just this information about what to do on that one particular frame. Okay, so let's go and set ourselves some keyframes to work with this, and then on this maybe on here I'm going to create an actual Houdini expression. Now don't worry about how I'm doing this. I mean, you can try and follow along, but I am going to show you later parameter expressions and how to work with them. But let's say we just go and do something like import the random module, and then we return random.random. Okay, so we've got a random value in here, and then we've got some keyframe in this. Okay, and now every frame this is reevaluating the random, and it's also doing this. Okay, and you'll see that because of the type of random that this is, even when we move back to the same frame, it's just different every time. Okay, which could be useful or could be annoying depending on which way you do it. Right, so these are the two kinds of things we're talking about, having an expression and a keyframe. And expressions can be Python expressions, but they can also be H script expressions, or you could have, say, dollar or something. You could use variables or whatever. For example, maybe a parameter reference. This channel reference over here is an H script expression. Okay, so these are like all the different types that we can have access to, right? So now let's just call these. So A is going to be this. B is going to be, I'm going to just grab this palm tuple and say 0 to grab that, and then same thing but index 1, and I'm going to call it C. Right, so A, B, and C are the individual palm references to scale, and then PRX and PRY. Now let's discuss what we can do with these. So keyframes, right? Let's start with A. So if we do A dot keyframes, what that's going to do is return a list of the actual keyframes themselves. Now, although this looks like a lot of information, really, if you look carefully, it's actually one long reference, comma, and then another reference, right? And what is this object? Remember, it's got the triangle thing. So what is this object? It's a who.keyframe object. So that will have its own parameters, functions and things to it. So we can go here and say who.keyframe class, and this will have its own functions, modules, everything inside of here. So on that keyframe, you can check the slope. You can set the value, you can, do whatever, check the in value, the in slope, the acceleration, all of that, okay? So it prints out in quite a large way that the repr function for this is quite large, but really it's just two objects, okay? So in fact, if we did this and we just grab the len of this, which tells us the number of items in our list, it just says 2, because we have 2 keyframes, which is exactly what we've got, okay? Right, and then let's do the same on B. So we say b.keyframes, and you'll see that it returns an object which is also a who.keyframe, but it has an expression attached to it. So it has literally expression equals, and then it has all of that code that we typed up to here, right? And then it has an expression language, and then still has all this sort of slope and acceleration and whatever. Okay, so it's storing that expression inside of a keyframe, right? And it's something you need to know, because if we, for example, delete keyframes, which is a function that we can do, then it's going to get rid of expressions as well. Okay, so that's how we can grab keyframes, and obviously we can loop through them and then perform the class functions from the keyframe class. don't forget as well, there are some cool things we can do. For example, like saying on A, which is our scale, we can say A dot keyframes after, and then pick a certain frame. So we say after frame 20, and then it'll actually give us only the one keyframe because there's only one that's after that frame, and you can do keyframes before or in a range. So it's quite cool. Now, expressions. So it's still the same thing, you know, we're still referring to, these are stored as keyframes, but because we want to grab this specifically, the actual string of the expression from a node, we can do that too, right? So we can say b dot expression, and that's going to return the expression like that. And you'll see that this is printed a little better than this. In here, when it prints the keyframe, it's actually printing it. So it's where it doesn't have the /n for the new line, it literally actually moves it to a new line. So this can print a little bit weird, but here it gives it to us in one go with the actual /n because I've put two open lines, right? So you can see it sort of printed that way correctly. Now let's see what happens when we go c dot expression, right? Same thing, just going to refer to that, and you see that it's printing both expressions. So there's obviously, we need to know the language because that's the difference between these two. It doesn't care, it's just a bunch of text. It's about how it should interpret those, and the language is what's important. And then when we say a dot expression, right? Well, okay, on A we need to assess each keyframe. You see on B and C they have only one keyframe, and so it knows how to get that. But we have to do it one keyframe at a time. So on A, we would have to do a dot keyframes, and then grab one index, so one of the keyframes, and then on that keyframe we would say dot expression, okay? And then what that's going to return is Bezier, and that, if you have you seen that, we see when you left click here, it shows you the expression itself, and it shows it for all of these as well. So you can actually see the expression in here, you can see the expression. And including here, we know that it's got a Bezier in there. So that's all it returns, okay? Because the data of that expression, it doesn't actually have an expression, so it just stores the word Bezier as a function sort of in that expression. It stores all the data of that, like the acceleration, the slope and everything, in other parts of that class, okay? But I just wanted to show you that you can actually grab the expression from keyframes as well. Right, so that's how we grab expressions, but now what about the language? So we can take A, for example. Well, again, we'd have to go a dot keyframes 0 dot expression language, right? And that's going to tell us what expression language that's in. And it comes in the form of a value within another module, right? So this is another module, who.expr language, so expression language, right? Who.expr language, right? Which actually it looks like it's a class, not a module. Dot, and then it's either got HScript or Python. Okay, I mean really, it's only the two. Okay, but those two values can be options, yes. So for example on B, when we say b dot expression language, it's going to return expression language dot Python. Okay. Now when we create an expression, so let's go and set, maybe let's go and set this. Okay, so I'm going to grab a reference to that, so that'll actually be I'm going to say d equals this and then the second index, right? So D is our PRZ. Now we can go and set an expression there. We can say P dot set expression. Whoops. Set expression. And then remember, okay, we're running it on the P, so we've already got self, but then we give it the expression, we give it the language, but it has a default of none. If none is provided, you'll see that it defaults to the HScript language. And then replace expression is set to true, as in it will just replace whatever expression is already there versus appending to it. So we say set expression, and then we give it whatever expression we want. So we just say something like print, and then I'm going to give it in double quotes here because we're inside of quotes already because we're giving it a string. and then we say language equals, and then we would have to go who.expr language.python. Okay, and that has done absolutely nothing. That's strange. Okay, hang on, let's try that again. Oh, sorry, I set it on P. I can't actually even remember which parameter was P, but that's funny. Not P, D, right? See, this is actually, I'm doing it now for convenience sake, but really when we do bigger scripts, we'll use more descriptive variables because this is not good. You should know which variable you're referring to. So yeah, there we are. We've set that and it's changed that to print hello. Okay. And then as we move, I mean, although that is not returning a value there, but it should actually be, printing. But yeah, when you have parameters printing, I mean, we'll talk about this later when we're doing actual parameter expressions, but you'll see that actually a lot of the time they don't print anything, although sometimes they do. So they're a little bit temperamental. But really what you're wanting to do is return a value like what's happening here. Printing is not really what parameters are for. Okay, so that's how we can create an expression and set the language of that expression. But there is not, okay, and you'd expect there to be a d dot set expression language, and unfortunately there is not. Okay. Now, according to the document, it says that this function is not implemented yet. So I believe that this is a function that is going to be added to Python soon, to Houdini's module soon. I don't know, maybe it'll be in 18 or whatever, but we'll see. So unfortunately, this is not an expression yet. The way that you are meant to do it is to say, so d.set expression, then set it to be equal to its current expression. So you give it, remember if we say d.expression, it's going to grab the expression language, well, sorry, the expression itself as a string. So we're essentially grabbing the value and setting it as its own value again, except that now we give it a different language. So now we would say language equals who.expr language dot, and then we would just change it to H script, okay, and then it changes that, okay, so it then switches it to H script. Now I have had many times where this very infuriatingly does not work, so it's funny that it worked now, because I actually probably would have preferred it to not work, so I can tell you how bad it is, because really you can't rely on this. It doesn't always work this way. And so a lot of the time what you actually have to do is go even more in depth than just one line. You have to store the expression, then clear the expression that is already there, and then set an expression with the stored value and a new language. All right, so that is a little bit frustrating, but okay, it's good that it sometimes worked, but I mean, let's see if we can do it the other way. If we convert it to Python, let's see if it works. Oh, it does. Okay. But take my word for it, sometimes it does not. It doesn't want to overwrite a certain parameter. Now, how you clear parameters and expressions and keyframes is, and because they are all treated as keyframes, this is one answer, which is to say d dot, and then delete all keyframes. Okay, or you can delete a specific keyframe. So delete keyframe at frame, and then you give it a certain frame, right? So delete all keyframes, and that clears the function, right? So it's like, you know, it's like going and clearing that, right? And then, like I said, if you wanted to, what you could do here is you would have already assessed, so evaluated what the expression is, stored this in a variable, then you delete all keyframes, so it goes back to being nothing. And then you say set expression, load the stored value, and then give it a language. And now because it's been cleared, it won't complain about having anything overriding it. Right? That's the real safe way to do it. Real bit of a workaround, which I don't really like. Another thing as well is if we have not expressions but actual just values, so we've got values like this, we can say d dot revert to defaults, and this function will actually just set it back to whatever the actual default is. Okay, so like if we control middle click, setting things back to defaults, right? This does that for us. Okay. So that about wraps it up for everything that I want to cover with parameters. Now, there obviously are a lot more functions which you can go through, but what I wanted to do is specifically show you the ones that you're actually going to use often and not to confuse you with 1,000 expressions. But please keep in mind there is a huge chunk here of things that we would love to do with parameters that we cannot do yet just using the who.parm or who.parm tuple class. We have to use the parm template class and other subclasses that are related to it. And it is something that I'm going to cover in a separate lesson. So for now, if you come across anything that is just unable to be done to normal parameters, just try and work around it or be patient. And very soon, in the next couple of weeks or whatever, we're going to cover it. I just need you to be a lot more comfortable with Python before we cover it, because it's quite it takes quite a bit to wrap your head around what it's actually doing. But I find it very fascinating to talk about it, because it kind of, once you understand how the Python is working, it gives you more of an insight into how Houdini works with HDAs, how Houdini works with its own node definitions, parameter definitions, where it stores the information for every parameter. So by learning it gives you more insight into how Houdini works, which is really cool. And I found that a lot, not just with these Parm templates, but with everything. When you start to learn Python, it's like you're peeking behind the curtain of Houdini, and now you actually start to understand more about what's going on in the background, which is pretty cool. All right. So I hope that was informative and you guys enjoyed that, and I will see you in the next lesson.